This means that this body is in stable condition if the body is not moving either in left direction, right direction, upward, downward. Though the forces are acting on this body, these are 1, 2, 3, 4 forces are acting, but the body is stable. It is not moving. The motion is not there in the body, and this body is in stable condition. Now, in simple language, the body is not moving. In technical language, the summation of all forces acting on the body is zero. In technical language, summation of all forces acting on body or object is zero. Okay, so this is in technical language. In simple language, body is stable, it is not moving. In technical language, summation of all forces acting on body is zero. Then only we may call this body is in equilibrium, or we can confirmly call this body is in equilibrium. But the forces must be zero. The summation of forces must be zero. Summation of forces must be zero means what? Now these four forces are there. These four forces are there. Their summation is zero. Their summation is zero means what? Their resultant is zero. All these four forces, their resultant is zero. Resultant is zero means what? Suppose that now we will consider horizontal and vertical forces. Okay. Now we will consider some another force. We will consider one more force. Okay. Now here also the four forces are there. Two forces are in vertical direction and two forces are in horizontal direction. Okay. Now let's also assume its magnitude. Suppose that this is having 10 Newton magnitude and this is also having the 10 Newton magnitude. Okay. And this force horizontal is having the 20 Newton magnitude, and this horizontal force is also having 20 Newton magnitude. Okay. These four forces are acting on this body. Okay. Now what will happen that this force 20 Newton is acting in negative x direction, while as this force is acting in positive x direction. This force 10 Newton is acting in positive y direction, while as this 10 Newton force is acting in negative y direction. So all these forces will cancel each other. Cancel each other means if we technically do here the summation of fx and summation of fy, then their summation will be here zero. Then their summation will be zero. If we go technically, by just observing this thing we can tell, but if we go technically, then fx will be equal to plus 20 minus 20, plus 20 minus 20, and fy will be equal to plus 10 minus 10. Okay, so their summation will be equal to 0. Their summation will be equal to 0 in both cases, and therefore R will also equal to 0 Newton. R will also be 0 Newton. So this means that their resultant is also 0. And if the resultant is 0, then this body is in equilibrium. Okay, so we have already discussed that there are three conditions of the equilibrium. That first condition is your summation of fx equal to 0. Second condition is sum of fy equal to 0. And moment at any studied the moment in detail, read this moment in very much detail. Okay, how to calculate the moment? So this one is the third condition, that if moment at any point is equal to 0, means if body is stable, if body is in equilibrium, then it must satisfy these three conditions. Then it must satisfy these three conditions, that summation fx is equal to 0, summation fy is equal to 0, and moment at any point is equal to 0. It must satisfy these three conditions. The body is stable, it proves its stability, and the body is also in equilibrium. So you note it down these things, that but many times the forces might not be such horizontal and vertical. The forces might not be such horizontal and vertical. If this force is not horizontal, then how we will calculate its exact value? If this force is not that much, what we can say, if this force is not that much horizontal, if it is inclined, then how you will calculate its value? Okay, now suppose that if this 20 Newton force is inclined at an angle of 45 degree, and this also inclined at angle 45 degree. Okay, then how you will do this fx and fy? How you will do this fx and fy? For fx, what will be your horizontal component? For fx, your horizontal component must be in terms of the 45 degree, means in terms of the cos, that is the cosine of theta. You have to split this force in two components. One will be horizontal, one will be vertical. One will be parallel to x-axis, one will be perpendicular to x-axis. Okay, now if your this angle is 45 degree, then the opposite angle is also 45 degree. This angle will also be 45 degree. Okay, by the property of opposite angle. Now if this angle is your 45 degree, then you can split this as 20 cos of 45 and 20 sine of 45. Okay, you can split it as minus 20 cos of 45 degree and minus 20 sine of 45 degree. Okay, so you have splitted this force 20 Newton into one horizontal component and one vertical component. Okay, you have to split this 20 Newton force also in horizontal component and in vertical component. So this one will be horizontal and this one will be vertical. Okay, so for horizontal, you have to write what is the angle, and that angle is also by the property of opposite angle. This angle is also 45 degree. This angle is also 45 degree. Okay, so therefore you have to resolve these forces also. Okay, this is horizontal line, and by the property of your opposite angles, these two angles are 45 degree, and you are going to resolve this force as plus 20 cos of 45 degree and this one as minus 20 sine of 45 degree. Okay, so in such a way you are going to resolve these forces, and you add these components into the summation of fx and summation of fy. Okay, and these summation, if this summation is 0, you add these forces here, and if this summation is 0, if this summation is also 0, then your fx will be 0, fy will be 0, resultant will also be 0. Okay, your minus 20 sine 45 and minus 20 sine 45 will get added here in summation of fy. Okay, in fx you are having plus 20 cos 45, in fx you are also having the minus 20 cos 45. All this addition will take place, and you are going to use the resultant formula, that is r is equal to under root of fx square, r is equal to, that is r square is equal to fx square plus fy square. This formula you are going to use, and if this value also becomes 0, then your resultant is in 0 and your body is in equilibrium, and your body is in equilibrium. Okay, so I hope that you come to know how we split these forces. Okay, if this vertical force is also there, if this vertical force is also inclined, then we can also split this force. Then we can also split this force. If this vertical force is inclined, if this is also inclined at certain angle, if suppose that this force is inclined with 60 degree, I am just giving you example. Okay, if this 10 Newton force is inclined with 60 degree, then you can also resolve this force as 10 cos 60, that is minus 10 cos 60, because it is in negative x direction, and minus 10 sin 60 in negative y direction. So in negative x direction, this will be minus 10 cos 60, and in negative y direction, negative x direction and negative y direction. Okay, minus 10 cos 60 minus 10 sin 60. You are able to resolve this force. Okay, and add these components into the summation fx, summation fy, whether it is applicable. Whether it is applicable. So by doing this type of summation, you are able to find the r, value of r. If your r is equal to 0 and your moment at any point is equal to 0, then your body is in equilibrium. It means that the overall force acting on body, the summation of all forces is 0, then only your body is in equilibrium. Okay, now if suppose that some duster is placed on the table. Okay, if suppose that you are having one table, okay, and a duster is there, suppose that a duster is there, a duster is placed on this table. Okay, a duster is placed on this table. Now what will happen here? Can this duster is also called as it is in equilibrium? This duster is also not moving. Okay, now here there is no force acting on this duster, then how this will be in equilibrium? Okay, so that thing also I will explain to you. This duster is having some its own weight, right? Duster is having, suppose that 100 gram weight is there. Okay, so the weight will be acting in downward direction. Weight will be acting in downward direction. That will be your W. Weight, remember, weight is also acting, weight always acting in downward direction. Okay, and according to the Newton's third law of motion, to every action there is equal and opposite reaction. To every action there is equal and opposite reaction. So therefore this W is the force exerted by duster on the table, and therefore table will equal and opposite force, and that force will be your reaction force. That force will be your reaction force, and that will be vertically in upward direction. So this will be your R. R is nothing but the reaction force. Okay, and now the value of W will be exactly equal to value of R. If W is 100 gram, then R will also be 100 gram. Okay, but gram is the mass. You have to convert the mass into Newton. If W is equal to 100 gram, then you have to convert this gram into the Newton. How you will convert the gram into the Newton? 100 gram divided by 1000. 100 gram divided by 1000 means you have to convert the gram into the kg. So therefore 0.1 kg will be there. 0.1 kg will be there. Now convert the 0.1 kg into the Newton. Okay, into the Newton. Okay, so how much kg will be equal to 1 Newton? That you should know, and after the conversion you will get the value exactly in Newton. Okay, so in this way you are able to calculate the reactions. Okay, so therefore if the body is not moving means it is in stable condition. If it is in stable condition means that the body is in equilibrium. If the body is in equilibrium means what? Here summation of fx equal to 0, summation of fy will be equal to 0, and moment at any point will be equal to 0. Now, as far as the Lamy's theorem is considered, yesterday we have seen the Lamy's theorem. So Lamy's theorem is also applicable to equilibrium. Okay, means the conditions were given such as the body is in equilibrium. The three forces should act on the body. Now this object is there. Now on this object, the three forces are acting. Here one object is there, and on this object, three forces are acting. And if the body is in equilibrium, if the body is in equilibrium means the body is not moving anywhere. The body is in stable condition. Okay, this is body A, and this body A is not moving anywhere. The body is stable here. Three forces are acting on this body. This is 10 Newton. This is 20 Newton. And suppose that this is 30 Newton. This is 30 Newton. And if the three angles are given, okay, three angles are given. Suppose that this angle is your 60 degree. This angle is your 60 degree. And this angle is 150 degree. Suppose that this angle is 150 degree. And this angle is also 150 degree. Okay, so how much is the addition? 150 plus 150, that is 300, and 300 plus 60, that is 360. So the addition of these three angles must be 360 degree all this circle, all over the circle. Okay, now what is the Lamy's theorem? That 10 Newton divided by sine of your 150, 20 Newton is equal to 20 Newton divided by sine of 150, and is equal to 30 Newton divided by sine of 60. So this is nothing but the Lamy's theorem that we have seen yesterday. In yesterday's lecture, we have seen this Lamy's theorem. Okay, so Lamy's theorem is very much simple, and you should be able to solve the numericals based on Lamy's theorem when the three forces are given, one force is unknown, or one angle is unknown. Remember this thing. When we will use the Lamy's theorem, when one force is unknown, either, or one angle is unknown. Okay, if two angles are same, then you can find the two unknowns. Okay, if three angles are different, then you can find the one unknown. Okay, so Lamy's theorem is used. It is used to find unknown force or angle. So Lamy's theorem is used to find the unknown force or unknown angle. Remember this thing. Okay, unknown force or unknown angle from the equation, and that equation we have seen yesterday. Okay, how you are able to find the unknown thing? Remember this. If this 20 Newton force is not given, if this 20 Newton force is hidden, instead of 20 Newton, if force P is there and you ask to find the force P is equal to how much, then you are able to find this force P is equal to how much by using the Lamy's theorem. Only the condition is that this body should be in equilibrium. All these three forces should be coplanar and concurrent. Okay, these three angles must be given and two forces must be given so that we can find the remaining third force. If two angles are given, then we can find the third remaining angle, which is unknown. Okay, so you can use the equation. You can use equation, whatever the equation that we have seen, that is the 10 Newton divided by sine of 150. 10 Newton divided by sine of 150 degree. Okay, then 30 Newton divided by sine of 60 degree here in this case, and third one is force P divided by sine of 150 degree as per the diagram. As per the diagram. Now these equations are there, and by using this equation, you are able to solve this. You are able to find the value of P. P is equal to how much? P is equal to how much? Okay. So try to find this on your calci. You are having your calci, you are having your notebook. Okay. So try to solve this numerical, write the answer in the chat box. Okay, so that the other students also come to know what is the answer. Okay, all students try to solve this, try to find the value of P. You know the conversion of degree and radian. You set in your calci, you can set the degree as a by default angle. Okay, you know sine, cos and tan, how to use it, how to use the equation. Okay, so to solve this, simply you can move this sine of 150 here. You can multiply 30 with sine of 150. 30 into sine of 150 divided by sine of 60. So that you will get the value of force P. So that you will be getting the value of force P. If you get the value of force P, you can also get the some other value. Okay. If two forces are unknown, then also you are able to get the two forces. Okay. If this instead of 10 Newton, if force Q is given, Q is equal to how much? Then also you are able to find this force Q. So instead of 10, you will be placing now force Q. Instead of force 10 Newton, one unknown can also be used. Okay, so here two unknowns can be find out. Either one unknown force or one unknown angle or two unknown force or two unknown angle. Okay, so you can find one unknown force and unknown angle, or any two unknowns, or any two unknowns you are able to find by using the Lamy's theorem. Okay, you can also find Q is equal to how much? Q is equal to how much? Try to find the answer and write it in your chat box. Okay, so now from this simple numerical, we get to know how we can find the two unknowns, either two forces such as the force P and force Q, or two angles. Okay, or two angles. Let's suppose that consider one more numerical on the Lamy's theorem. If three forces are given, you try to solve that numerical. Okay, if now these three forces are given, okay, having magnitudes, A is equal to 10 Newton, these three forces are given. B is equal to 20 Newton and C is equal to 30 Newton. We are taking the simple numericals, not the complicated one. Not the complicated one. We are just assuming the simple numericals. Okay. Now, one angle is given. One angle is given. This angle is given as 120 degree. This angle is given as 120 degree. Now, are you able to find the unknown angles by using the Lamy's theorem? Are you able to find the unknown angles by using the Lamy's theorem? So that is we are going to see now. Okay. Now, by using the Lamy's theorem, how you will be getting the equation? First one is A. A is equal to 10 Newton. 10 Newton divided by sine of. Now, here the angles are unknown, and therefore, let's assume this as theta 1 and this as theta 2. Theta 1 and theta 2 here are unknown. So therefore, 10 Newton divided by sine of theta 1 then 30, that is the C, divided by sine of theta 2, sine of theta 2. Then next one is B force, which is 20 Newton. 20 Newton divided by sine of 120 degree. Sine of 120 degree. Now you try to find the answer here by using the Lamy's theorem. By using the Lamy's theorem. Okay. Try to find what is the value of theta 1 and theta 2. How much is the value that you try to find? Already the equation has been written now. Equation is also given. Use this equation to find the value of two unknowns. Now, are we able to find the two unknowns? That we have to see here. This is, I think, numerical number 4 on Lamy's theorem. Yesterday we have seen the numerical. This one is the numerical number 3 on the Lamy's theorem, right? This one is the numerical number 3, and this one is the numerical number 1 and 2 we have seen yesterday, and this one is the numerical number 3 and 4 for today. Okay, so try to solve this and get these answers. Also, you have to write this all numericals in your notebook, in your regular notebook, and whatever the homeworks are given, that homeworks you have to solve in your assignments. So for unit 1, assignment number 1 will be which? In assignment number 1, whatever the numericals we have given for homework, that all numericals will be in assignment number 1. Okay, and we will be ending our unit number 1 in few days. In few days, 1 or 2 days, our unit 1 will get ended. Okay, now there is another method to solve this numerical. Which one is the another method? The another method is to use the simple resolution. Resolve this 20 Newton force in X and Y component. Resolve this 10 Newton force in X and Y component, and try to use the resultant formula to find the unknown values. This is the another method to use to solve this numerical. But that method is long, so that's why we use the Lamy's theorem, which is the shortcut method. Okay, so our time has ended here, and our